Aloha. Welcome to my presentation about the rise, fall and reinvention of IBM in artificial intelligence. IBM's story in artificial intelligence reads like a Greek epic, moments of astonishing triumph followed by equally dramatic decline. In 1997, the company's computer Deep Blue stunned the world by defeating Garry Kasparov, the reigning chess champion. That victory was more than just a game. It symbolized the arrival of machines that could challenge human mastery in complex domains. A decade later, Watson brought IBM back into the limelight when it defeated champions on the television quiz show Jeopardy. For a brief moment, the company was not just part of the AI conversation, it was the conversation. After Watson's Jeopardy victory, IBM executives envisioned a future where their AI system would revolutionize entire industries. Watson was marketed as a doctor's assistant, a legal researcher, a financial analyst, and even a friendly customer service agent. The branding was bold. Watson would not just analyze data, it would understand language and reason with human-like intelligence. Billions were invested in building an AI consulting empire around it. For a few years, Watson was a household name, and IBM seemed poised to become the king of AI. So, why didn't IBM hold on to its throne? The answer lies in both technological shortcomings and deep corporate habits. Overpromising, underdelivering. Watson was a remarkable system for a quiz show, but less suited for messy real-world data. Hospitals that piloted Watson for cancer diagnosis found it expensive and difficult to integrate into existing workflows. Banks and insurers faced similar frustrations. The technology, impressive in a demo, struggled to scale in practice. Corporate inertia. IBM's DNA was formed in the era of mainframes, when it reigned supreme over enterprise computing. But history shows that when technology shifts, IBM tends to lag. In the 1980s, it entered the personal computer market late. To rush into desktops, it outsourced the operating system to Microsoft and the processor to Intel. Experts generally agree that the IBM PC architecture is not as good as its rivals. Its cautious, bureaucratic style, effective in selling to governments and Fortune 500 firms, proved a liability in fast-moving consumer and software markets. The same inertia haunted its AI efforts decades later. The cloud revolution. By the time Watson was making headlines, rivals like Amazon, Google, and Microsoft were embedding AI directly into their cloud services. They offered scalable, pay-as-you-go APIs that allowed startups, researchers, and enterprises alike to harness machine learning with minimal friction. IBM, in contrast, stuck with its traditional model of high-touch consulting and enterprise deployments. In a world where agility was king, IBM felt heavy, expensive, and slow. Missing the opportunity of emerging synergy of data science and artificial intelligence. Artificial intelligence and data science have always been symbiotic. Artificial intelligence relies on statistical modeling, and data science provides the methods to train and evaluate intelligent systems. IBM seemed to recognize this connection in 2009 when it acquired SPSS Statistics, a program long favored in academia for its approachable interface and data analytics functionalities, including decision trees and even neural networks. The acquisition gave IBM a chance to extend its presence in the AI and data science market, since generations of students were already learning SPSS in universities worldwide. But IBM never capitalized on this advantage. Unlike rivals that continuously modernized their ecosystems, SPSS Statistics remained largely static. Its outputs are frozen and unalterable, rather than dynamic and interactive. While JMP, Python, R, JASP, the GUI version of R, and later cloud-based tools surged ahead with flexibility and openness, such as developing dynamic data visualization, SPSS Statistics stagnated. As open-source platforms democratized data science and AI labs captured public imagination, SPSS statistics lost ground. Unlike SAS Institute, which retained a loyal following in highly regulated industries such as banking, insurance, and pharmaceuticals, SPSS had no equivalent base of enterprise users outside academia. As a result, IBM missed the opportunity to become a serious tool for modern AI or data science. The generative AI leap. The knockout blow came with the rise of generative AI. Systems like OpenAI's ChatGPT, Google's Gemini, Anthropic's Claude, and Meta's Llama could produce human-like text, images, and even video. Suddenly, the public face of AI was creative, conversational, and accessible. At first glance, Watson, designed for structured business data and expert-driven projects, seems archaic. Nonetheless, although it is no longer part of the cutting edge, it is still capable in specialized domains. IBM today, a faded star, but still a steady player. In today's headlines, Watson has all but vanished. OpenAI, Google, and Anthropic dominate public imagination, while IBM has receded into the background. But declaring Watson dead would be misleading. IBM has repositioned itself with Watson X, focusing not on mass consumer use but on enterprise AI that emphasizes trust, governance, and compliance. Watson X helps banks check regulatory reports, supports lawyers with contract analysis, and automates HR processes. In these contexts, flashiness matters less than reliability. A bank doesn't want its AI generating poetry, it wants models that can explain decisions in an audit. Here, IBM's slow, cautious style is a feature, not a bug. The Academic Bridge, SPSS Modeler. IBM also remains visible in academia. Its SPSS Modeler, a drag-and-drop data mining tool, is offered free to students and faculty through IBM Academic Initiative. Unlike some free software applications that come with restrictions, the academic version of SPSS Modeler provides access to its premium module, which includes advanced capabilities such as text mining and natural language processing. With flowchart-style workflows and automatic model comparison features, it remains a practical teaching tool, especially for those who want to focus on concepts without diving into programming. Crucially, SPSS Modeler is fully integrated into the IBM Watson Studio and IBM Watson X.AI platforms. This allows users to create visual flows or streams in Modeler to prepare data and build predictive models, all within the collaborative Watson environment. SPSS Modeler's connection with Watson AI allows educators and students to move from classroom exercises into enterprise-grade applications. This illustrates IBM's enduring strength, not as a pioneer of bleeding-edge AI, but as a bridge between education, research, and practical business use. Lessons from IBM's journey. The rise and fall of IBM in AI mirrors its larger corporate history. The company was once dominant in mainframes but ceded leadership in personal computers to faster, leaner rivals. In AI, it again claimed early glory but was overtaken by nimbler players who embraced cloud platforms and generative models. IBM's very size, long history, and reliance on established enterprise habits, the very factors that made it powerful in one era, became obstacles in another. Yet IBM's story also reminds us that not all value lies in being on the cutting edge. For universities, hospitals, governments, and corporations that care about stability, compliance, and trustworthiness, IBM remains a partner worth having. Its crown may have slipped, but it still wears the armor of reliability. In summary, IBM rose to fame with headline-making achievements in artificial intelligence like Deep Blue and Watson, but struggled to turn those moments into lasting dominance. Slow to pivot in the cloud and generative AI era, it yielded the spotlight to faster rivals such as OpenAI, Google, and Anthropic. Even so, IBM has not disappeared. In areas where trust, governance, and compliance matter most, banking, insurance, government, and academia, it still provides steady, reliable tools. The lesson here is clear. Even industry giants can falter if they fail to adapt quickly enough. IBM helped shape the modern story of AI, yet today it stands at a crossroads. Will it fade into history like Kodak or Blockbuster, remembered more for what it once was than what it became? Or can it reinvent itself once again, bringing Watson, a successor, or another type of revolutionary technology, back to the front stage? While it may no longer be the heavyweight in artificial intelligence, IBM's story is not finished. Beyond AI, another technological frontier is emerging: quantum computing. IBM has been investing in this field since the 1980s and remains one of the most visible corporate leaders today. In 2023, it unveiled Condor, the first publicly announced quantum processor with over 1,000 qubits. But IBM's ambitions go further than bigger chips. Its vision is to build a full quantum-centric supercomputer, blending quantum and classical systems to solve problems far beyond the reach of today's machines. If IBM succeeds, its reputation could once again soar, perhaps even eclipsing the current spotlight enjoyed by OpenAI and Anthropic. So, what do you think? Please drop a comment here. If you found these reflections useful, consider sharing them with others who are curious about the past, present, and future of AI. Thank you for watching. Mahalo.